Hi, I'm Christopher Owen, and this is my code demonstration for the Artificial Neural Network Digit Recognition Program, CS4242, Artificial Intelligence, Section 01, Fall Semester 2016 at Kennesaw State University. All right. So because of the sheer number of different working parts in this project, this time I opted to do something a bit different from my previous ones. I used several different Java classes instead of just using one or two. Not including the training files I have over here and the results CSV files and the one that I actually write to right here. I have 5 total Java classes that I use. The digit recognition.java, the layer.java, the network.java, the neuron.java, and the neuron connection.java. But we're going to start with the digit recognition.java. So for starters, it sets up my matrix that will be inserting sequences of numbers from the training and test files into it for learning, validating, holding on to the location of my training and test files, hold on the number of training digits and testing digits, and number correct digits. These are all my globals right here that I use. I then create a buffered writer, which will write to a results CSV that I showed you a second ago that holds number of training files trained against and accuracy for testing against the test file. Below here, let me scroll down. Below here, I made several getters and setters below for easy manipulating of the numbers, where I'll be needing quick access to the global variables so I can write to them. We then have the append results, which is previously stated, writes the results to my results.csv and actually does the calculation to determine the accuracy of my artificial neural network's guesses, which is done right here. The double this dot get num correct, double divide by double this dot get test count times 100, which gives you a percentage that you can look at and make sense of instead of having to move the decimal. The rest of the methods of this class are fairly straightforward. The train model, which is all of this, reads data from a specified training file to train the neural network. The train model with sample trains the neural network using specific sample data read from file, looks up the output neuron for the character to train. If the character has not been trained before, it adds it to the output layer, and finally trains the network with the current sample digit applied to the output neuron. So then we have recognize digits and recognize digit. Recognize digits reads data from a specified test file to test and validate the neural network, and tests and validates the neural network using specified sample data read from file. And recognize digit fills the input layer. Yeah, right here. So next we have normalize sample. This method normalizes input values to the neural network. This means that input values 0 through 16 are too variable for the learning algorithm to process, so the input values are normalized either 1 or -1, have data or they do not have data. And then we just have print layer, which prints the specified layer connections and neurons. And we finish up the class with the main, which is the main entry point, where the training and test files are set. The training of the ANN goes on and is eventually appended to the CSV file. All right, so now let's move to the layer. I'm going to try and summarize these as quickly as possible because doing so, like going into specifics, will take a lot of time. So this the layer.java is a class that represents a layer list of neurons. In summary, this class constructs the specified layer, creates a specified number of neurons for the layer, and has a getter and setter for the name of the layer, has a getter and setter to set the list of neurons for this layer, and has a method to activate each neuron in the layer to produce output, which is the think method right here. And it connects the specified neuron to all of the neurons in this layer, gets the specified neuron by name. The neuron name will be the digit it represents. And finally, it finds the neuron with the highest value in this layer, and that would be this best guess method. All right, the third class we have is the network.java class. This class is the main neural network class, a feed-forward neural network. In this network, the information moves in only one direction, forward from the input nodes through to the output nodes. There are no cycles or loops in this network. This class holds references to the two layers used by this neural network, the input layer, the 64 elements in the array containing the NIST data for each sample, and output layer. And the output layer, the 10-element array containing the 10 digits to be recognized. The numbers that we're going to be recognizing, it's only 1 through 10. It's nothing more than that. To summarize specifically the working parts of the layers.java, it constructs the networks. It creates the two layers. Has a getter and setter to retrieve and set the layers. Has a method to activate the neurons that make up that layer to produce output. Has a method to activate the layers to produce output. Each layer in turn will activate the neurons that make up that layer to produce output. It trains an output neuron with the specified sample data of a known recognized digit, and finally it adjusts the weight using the delta. Alright. The fourth and fifth class is the neuron.java and the neuron connection.java. The neuron.java is also in charge of, the neuron.java contains the code to calculate a value and is responsible for generating an output value. Neuron.java is also in charge of constructing a neuron using the specified name, 0, 1, 2, 3, etc. Initializing the neuron list connections and setting a default value has a getter. It has a getter and a setter for the name and value of the neuron, and it has a getter and setter for right here the connections, for the list of connections for a specific neuron, and it generates an output value based on the input values multiplied by the corresponding weights. This is also where we have our sigmoid function right here. And that's where that comes into play. Finally, we have the neuron connection.java. It constructs a neuron connection using the specified neuron, has a getter and a setter for the source neuron for this connection, and has a getter and a setter for the weight for this connection. Alright, and that's all of our Java classes. So the last thing that is worth mentioning is my training digit text files. As previously shown right here, I took the original file, the original training file, which had well over 1,000 sequences of numbers, and made subsets of these increments in tens. You can see the tens right here. And then I did it in 100s in order of value. And I executed that, and you can see it in here, the 10s, 20s, 30s. It goes up, and it learns, it becomes more accurate, and then eventually plateaus. So now I'm going to do, I'll actually run the code for you to show how, show that it works. First though, to do this, you have to go into digit recognition, go to run as, run configuration, go to arguments, and I'm going to try and do the whole training file. So I'm going to do that, apply, and run. So we see we have, it's done all of the training digits. Now we can go, done all the training digits and test digits. We'll go to our results. There's a new file, and it went through it tested every training digit and went through the test digit, and the accuracy of the test file is 83.19%. Thank you for watching.